Okay, here's notes 4. We're going to be applying the distributive property. So put apply the distributive property up here at the top on the topic. Okay, so make sure you put your name, today's date, and the period that you're in. And the essential question is what I want you to fill in is to explain how to do distributive property. Okay, so I just wrote an essential question down. You can have this one or one on your own, whichever you prefer. Just write one down that you think is just what I wrote was how to simplify an expression using distributive property. I've got some vocabulary words I've got to write down. So there's 1, 2, 3, 4, 5. There's 6 vocabulary I'm fixing to write down that you have to copy down also, so that we're all talking about the same things. So I'm going to write the words on this side. And then I'm going to define them on the notes side here. So the first one is equivalent expressions. Okay, so what I have here is equivalent expressions is where it has 2 expressions that have the same value for all values of the variable. They'll equal each other. Okay, I'm going to change colors now so that it's easier to see. So the next one is the main one of this unit. Okay, so I have distributive property. Okay, so what I have here is the distributive property is used to find the product of a number and the sum or difference of other values. Okay, I'm going to change colors again. Okay, so I have the word terms. Okay, the terms are the parts of an expression that are added together. Okay, so terms are just the individual pieces that are being added together to make them terms. Okay, so I'm going to the next one now. Let's go with this one. Okay, the coefficient is going to be the number part of a term that has a variable. So for example, a term would be like 5x, and the coefficient on this one of this problem, 5x, would be the 5. That this would be your coefficient, because it has to be with a letter. So a term would just be like 5x, and a coefficient would be the 5 part of the term. Just so you see that. Okay. Alright, we got two more vocabulary words. So we have constant term, okay. A constant term, it says, is a term that is a number, but there is no variable part. So that just means it's like the number 4 or 5 or 10 or -10 or something like that. Okay, and then last vocabulary. Here's the last vocabulary words. Let me slide that up. So it'd be, the last one is like terms. Okay, so for like terms, they are all individual terms that have the same exact variable parts. And remember, these variable parts must be exactly the same. There can't be any difference in the letters for the vocabulary here. Alright, I'm going to start writing our first example. Make sure you copy down the words for the first example because it's kind of long. Okay, on example 1 it says, okay, we're going to apply the distributive property, which is what we're doing in this section. Okay, it says use the distributive property to write an equivalent expression. So we want it to be equal. So for our first example, or trying to understand this, is suppose we have 4 times a plus 3, and to show or illustrate this, we're going to do the product, because it says distributive property is the product, so we know that product means we are multiplying. So that means on this first one I'm going to do 4 times a, which realize A does not have a number in front of it, so therefore it is understood to be the understood 1. So basically I'm saying, okay, I'm going to multiply 4 times 1A, and then I have my plus, and then I'm going to multiply 4 times the positive 3, so I'll have 4 times 3. This is distributing it in because the 4 has to be multiplied times each term on the inside. If I actually write this out, this would be 4 times 1, which is 4, and bring the A over, plus 4 times 3, which is 12, and this would be your equivalent expression. Okay. If I do a second one, suppose I have negative 3 parentheses x minus 8. Just to show you this expression, I am still going to multiply negative 3 times the x, which remember there is an understood 1. So I'm going to do negative 3, this is what I'm thinking, times 1x. This is my thinking pattern here. So what I'm going to do, negative 3 times 1 is a negative 3x. And now I need to multiply what I'm thinking is negative 3 times this negative 8. Now, this symbol goes with the 8. It does not go alone. I don't bring it down. This is part of this sign. This is where we used to do in 8th grade, plus the opposite. We've got plus the opposite. That 8 is negative, and that's what I'm bringing over. Make sure your sign is okay the way it is, because now I do negative 3 times negative 8. Well, negative times a negative turns this to a positive, and that's the plus sign that comes down. And then 3 times 8 is 24, and this is our simplified expression. Okay. What if it's backwards? Suppose I have a plus 5 and then a 6 is on the back side of things. Well, I have two options. I can either go ahead and multiply it backwards, which is alright. I can do 6 times this a, which remember there's an understood 1 in front of this. Let me change colors here. So that would be 6 times 1a. Well, 6 times 1 is 6, and then I just bring the a over. And then my next step would be to multiply 5 and the 6, which is 30. 5 times 6 is positive 30, so I'll put a plus sign. Realize if you don't like the 6 behind it, okay, if you don't like it behind it, rewrite it. Rewrite it to where the 6 is now in the front, and you have a plus 5. And you'll do the same exact thing. There is no problem with the backwards or the forwards, because when you multiply it in, 6 times 1a is still going to be 6a, and then 6 times the 5 is still going to be 30. It does not matter, we get the same exact answer regardless of whether the coefficient is in front or behind. Now I just used the word coefficient, I didn't explain it. This term out front, it's out all by itself, it's out front of this expression here. This one is called a coefficient, as well as the 1 inside, that is called a coefficient. Coefficient just means it's outside, it's a number that is outside of a term. Alright, I'm going to flip my page over and write some more examples on the back. If you're out of room, do the same. Alright, example 2 wants us to identify parts of an expression. So I'm going to say identify the terms, coefficients, and constant terms of the expression. Okay, identify the terms, the coefficient, and the constant terms. If I give you the expression 2x minus 5 plus 8x minus 3. Here's a long expression. It has 4 terms in it. So if I'm going to actually do the first step, which is identify the terms, I'm first going to write the word terms, put a colon, and now I need to write each one of these items. Realize terms are separated by your plus and your minus sign. So it's like I'm putting lines between each one of those and writing them down here. If I start out, let me take a piece of paper and cover up. My first term is just the 2x. Then I need to put a comma, because now I need to cover up the 2x and then open it up until I see the next term. Okay, the next term, there's the next sign, so I got to cover up. So this is my next term. Notice the negative, or the subtract, is with the 5. So that means this is a negative 5 is my next term. So now I want to cover up the 5 and open it up until I get to the next sign. There's my subtract, so bring it back. There is my next term, is a positive 8x. So I'm going to put a comma and then an 8x. I'm going to cover this up and now slide it out until I see the next column. Oh, there I'm at the end. This is the last term. Notice I have a subtract, so I have to have a comma, negative 3. That is very, very important. You understand that the negatives, the subtracts, come out with the term as a negative. Alright, next is coefficients. Okay, if I look at my coefficients, I'm looking at my terms, and I look at only the ones with letters. These two. So with the one with the letters, I look at the number that's with the letter. So I see that this first one has a 2, comma, and then the second term that has a letter or a variable is an 8. So these guys up here are the only ones that have coefficients. These other numbers are not coefficients. The final identifying is a constant term. After I have already used the ones that have the variables, the ones that remain by themselves, they are just a number, nothing else. Those represent my constant terms. And look at your terms you have here. That way you get your signs correct. Because I have a negative 5 for one of them, make sure you put a comma, and then a negative 3 for the second constant term. Okay. Now I'm going to give you some independent problems I want you to work. I'm going to write them down. You do the same. I want you to work them on your own, and when you're finished, I want you to show it to me, or raise your hand and I'll come over and look at what you've done. If it is correct, I will give you your worksheet to start working on. Okay, I need to add one thing I just noticed. Right here in the practice problem, it has the word like terms that I did not identify up here on this example 2, so I want to add it on there for like terms. Like terms will be the ones that have both variables, so these two together will be your like terms. So this is where you put 2x comma 8x. So those will be like terms because they have the x's together. Those are like terms. And then also I want to put that, whoops, let me change colors. That is saying that this and this term, these two guys together will also be like terms. And make sure you put commas between them, because realize these are your variables with coefficients, and then the bottom ones are your constant terms. So realize like terms covers all of them, but you're grouping them. So make sure you have them grouped together and that it's obvious. So if you put these all in a line, make sure that you add like a semicolon between them so that you can see that these two are together and these two are together. Okay, so let me leave this up. I want you to work these problems. Once you have them all completed, raise your hand, and do realize you can talk to a neighbor to guide you a little bit on what you are working.